Welcome to the Bbanauliwood film city, and I am Einstein, and today I am going to discuss about the original Einstein's mass energy relation, that is equals to m into c square. Here we are considering the variation of mass with velocity, and also we will show the stored potential energy of a spring compressed by tying it in together and then completely dissolved in acid. So let us start with fake Einstein. So first we see the fake original Einstein's mass energy equivalence relations. So according to Einstein's special theory of relativity, the mass m of a body moving with velocity v relative to a stationary observer varies with v and is given by the relation m equals to m naught divided by under root 1 minus v square by c square, where m naught is the rest mass of the body and c is the velocity of light, and this is expressed by equation 1. Now the variation of mass with velocity has modified our ideas about energy. Consider a particle of mass m acted upon by a force F in the same direction as its velocity v. The force is defined as the rate of change of momentum, so we can write F equals to dp by dt equals to dmv by dt, or after differentiation we get F equals to m into dv by dt plus v into dm by dt. Here m is variable. The work done by the force F in displacement ds of the body is equal to the change in the kinetic energy K of the body. Here kinetic energy is represented by K. Thus we can write dk equals to F into ds equals to m into dv by dt into ds plus v into dm by dt into ds, or equals to m into ds by dt into dv plus v into ds by dt into dm, or equals to mv into dv plus v square dm, because ds by dt equals to v. Now we will differentiate the equation 1, that is m equals to m naught by under root 1 minus v square by c square. So we will get dm equals to m naught into open braces minus 1 by 2 into close braces into open braces 1 minus v square by c square close braces to the power minus 3 by 2 into open braces minus 2v into dv divided by c square close braces, and solving it we get dm equals to m naught by c square into v dv divided by open braces 1 minus v square by c square close braces to the power 3 by 2. But we know that m naught equals to m in m naught equals to m into 1 minus v square by c square whole to the power of we have m naught equals to m into open braces 1 minus v square by c square close braces to the power minus 1 by 2. So using this in equation, above equation we get dm equals to m into v dv divided by open braces c square minus v square close braces, or m into v into dv equals to open braces c square minus v square close braces into dm. Now using this equation in dk equals to mv dv plus v square dm, we get dk equals to open braces c a square minus b square close braces into dm plus v square dm equals to c square dm. Suppose the body has a mass m0 when at rest and a mass m when accelerated to a velocity v. So the kinetic energy acquired by this body is k equals to integration dk equals to integration m0 to m c square dm equals to c square into open braces m minus m0 close braces. This is equation 3. This result shows that kinetic energy of a body is equal to the relativistic increase in the mass of the body over the rest mass multiplied by the square of the velocity of light. It can be interpreted to mean that even when the body is at rest, it possesses an amount of energy m0 into c square. Accordingly, m0 into c square is called the rest energy, that is E sub 0 or E0 of a body whose rest mass is m0. The total energy E of the body is therefore the sum of the kinetic energy and the rest mass energy. Thus, E equals to k plus E sub 0 equals to open braces m minus m0 into c square plus m0 into c square. So E equals to mc square. E equals to mc square. This is the famous Einstein mass energy relation. This shows that with the mass m of a system is associated an amount of energy m into c square. Conversely, a system with total energy E has associated with it an inertial mass E by c square. Whenever we supply any kind of energy to a body, the mass of the body increases. In fact, a body when heated becomes more massive. For example, if we supply a quantity of heat delta Q to a body, its mass increases by an amount delta Q by c square. Thus, whenever we supply an amount of any kind of energy delta E to a material body, the mass of the body increased by an amount delta M equals to delta E by c square. Now this relation has been verified by several examples. So let's see this phenomenon to verify the mass energy relation. For first example, we see the Compton effect. Compton treated the X-ray scattering as an elastic collision between a photon and an electron, after which the scattered photon moves in a new direction and the electron recoils with a velocity comparable with the velocity of light. Applying the law of conservation of energy and momentum in the light of mass energy relation, Compton calculated a value for the wavelength shift which agreed with the experimental result. Second verification, fine structure of a spectral lines. Sommerfeld explained the fine structure of spectral lines on the basis of a relativistic variation of mass. The nice agreement of his theory with experiment provide another verification of mass energy relation. And the third one, nuclear phenomena. The explanation of mass defect and release of tremendous amount of energy in nuclear fission, which is entirely based on mass energy relation, gives a strong support to this relation, that is E equals to m into c square. Now the compressed spring dissolved in acid. The explanation of this effect. The idea of mass energy equivalence can be extended to energy other than kinetic. For example, when we compress a spring, we give it an elastic potential energy delta U let, and its mass increases by an amount delta U by c square. Thus, the mass of a compressed spring is greater than that of an uncompressed one. If the compressed spring is dissolved in acid, the reaction products are of slightly greater mass, though undetectable, than if the springs were uncompressed. So with this, I would like to end this lecture here. So Einstein have discussed the mass energy relation of original given by original Einstein. Thank you very much to watching my video and supporting me.